Welcome back. For the final episode, we're going to discuss what you can do to make your digital operations resilient and improve your operational excellence when using the cloud. We've already touched on the principle that you need to build systems that embrace failure as a natural occurrence. Another guiding principle from our EC2 team is that you can't legislate against failure, but you can focus on fast detection and response. So let's explore a little more on how you can use some of the tooling and best practice guidance we provide to help you build very resilient applications. I'm pleased to be joined by Alex Meek-Holmes from our International Central Government team. He has previous experience in delivering digital services across the UK government and managing the national cybersecurity strategy across UK industry. And at AWS, he advises governments on cloud adoption for nation-scale resilience. Hi, Alex.
Hi. In my day-to-day role, I work with governments who, like many organisations with highly regulated workloads, require a high level of availability. There are a number of different options and tools that I recommend to them to support this. But before we get to those, I think it's worth reiterating that in the same way we say security is a shared responsibility, resiliency also follows the same model. As you have discussed previously, AWS has invested, innovated and re-innovated to provide customers with the most resilient cloud infrastructure. However, it's up to customers to decide ultimately how much resiliency they build into their own environments. In short, it's an active choice.
That's an excellent point and serves as useful context that what we discuss now comes down to the design choices that customers make when building in the cloud. When talking to customers, I usually emphasize the importance of understanding the concept of the different fault isolation boundaries, which minimize the scope of impact if a failure does occur. Within AWS, that's regions, availability zones, control planes, and data planes.
If an organization is thinking about operational excellence, what are the key takeaways around the concept of fault isolation they should be thinking about?
I would say availability zone independence, because this allows us to offer customers zonal services like Amazon EC2 and Amazon EBS. We covered this briefly in episode 4, but as a reminder, these provide the ability to specify which availability zone the resources are deployed into. These services operate independently in each availability zone within a region, and more importantly for your resilience, fail independently in each availability zone as well. Building across multiple availability zones should really be the starting point for resilient applications.
That is such a fundamental fault isolation boundary. A question that often comes up when I first start talking to governments about cloud adoption is, what happens if all of a service like EC2 goes down? But the zonal fault isolation boundary means that services like EC2 fail independently within an individual availability zone and not more widely.
Thinking of containment of issues within availability zones, one AWS tool that comes to mind that you can deploy to recover fast in the event of things going wrong is our Application Recovery Controller, or ARC as it's known. This has a lot of useful features to rapidly recover from application failures and also includes a zonal shift feature which will automatically shift your traffic away from an AZ when we detect potential issues. It can move an entire application stack en masse.
Yes, and what I love about ARC is the fact that a lot of its features to support recovery can be automated. Automation is another important resiliency concept we often talk to customers about when helping them to become operationally excellent in the cloud. Being resilient often means looking for opportunities to take the human out of the loop. In the cloud, more so than on-premise, you can automate a lot of proactive responses to managing your infrastructure.
Yes, if you're carrying the pager for a critical service, then you want to try and avoid getting an alarm at 4 a.m. because something has gone wrong that needs manual attention. I mean, who wants that? Automation certainly can help mitigate some of those problems. AWS Autoscaling is a perfect example. This is a way of automating your infrastructure to self-heal. If we take EC2 as an example, you can create collections called auto-scaling groups. One approach is to specify a maximum and a minimum number to ensure that the scale never goes above or below this size. This might be useful if you want to be able to keep within a budget or know with some certainty what minimum or maximum capacity your application will have. Or you could specify the desired capacity. Autoscaling will ensure that your autoscaling group has enough instances to meet that capacity. By joining forces with the Elastic Load Balancing service, it monitors the health and availability of your instances. But it goes further and replaces terminated or impaired instances to maintain this capacity. You can even specify multiple availability zones for your autoscaling groups. Again, this provides high availability and resilience. And most importantly, there is no need for manual oversight here. You set the rules and then you use this service to monitor your applications, and it automatically adjusts capacity to maintain a steady, predictable performance.
Another question that comes up is, I've built an application that follows AWS best practice as defined in the well-architected framework, but how do I actually test it for resiliency? How do I know how it will behave if things start to fail? Well, one service that's great for that is one that you were talking about in a previous video with Elaine, who's responsible for the service, and that is the AWS Fault Injection Service. This is a great service that customers can use to proactively test their application resiliency. It provides templates that generate disruptions, the outcomes of which you can use to improve an application's performance, observability, and resilience. It's a great way to gain real-world scenarios to test how resilient your applications are without the stress of an actual real-world event. I certainly have some scars from managing on-prem infrastructure that would have been avoided if I'd been able to stress test them like this.
Certainly a very useful service for that, I agree. It also helps customers establish their operational plans for possible failure, right?
Yes, it allows you to build confidence in your application behavior. It helps you test how your recovery procedures work beyond the technology. Planning how the organization reacts to a technology failure is something we advise governments about as part of their resilience strategies. The Fault Injection Service is a great tool for organizations to use to test the operational process in response to different failure scenarios as part of a broader resilience planning program.
That's a good point. Being operationally excellent goes beyond how you build applications in the cloud. It must also include organizational best practice and mechanisms that create the foundation for resilience. Getting the basics right, like having properly structured code reviews, robust deployment pipelines to deliver and manage changes to critical services, and understanding the dependencies within your services and across your application teams.
And of course, if you're going to catch faults before they have a significant impact on your service, you need to ensure you've got the right observability and monitoring in place. I think this is often the most important and most neglected aspect of achieving a strong resiliency posture. Specifically, customers should ask themselves, what are we measuring? It needs to be more than just availability of the application front end. The cloud gives you the ability to monitor so much. Everything in the cloud, in terms of the services you use to build your applications, are API driven. An API is a communication layer between the applications that facilitates the ongoing series of requests and the responses between your services. So with modern cloud-native applications, you can independently monitor and measure how all of these components are interacting and performing. You can also aggregate metrics and define composite alarms to give a better view of application and infrastructure health, making it easier to identify the root cause of an issue and recover more quickly.
Separating the signal from the noise through better granularity of how each component of your service is performing is critical to fast detection and response. So another core AWS service that customers should really embrace and get to know is Cloudatch. This is a monitoring and observability service provided by AWS for all the services you might be using. It collects logs, metrics, and event data that you can incorporate into your own service dashboards.
Cloudatch is such a core service, but did you know it also has some cool diagnostic features such as synthetic monitoring, or canaries as they're often known. Canaries perform the same actions as a customer, following the same route through the application, which makes it possible for you to continually verify your customer experience even when you don't have any customer traffic. By using canaries, you can discover issues before your customers do.
So, to return to where we started, be alive to failure. Make choices in how you architect and operate to decrease the impact of it. Alex, what do you tell governments when they ask you about failure?
I share with them what we've learned in AWS is that you can't legislate for failure, It happens and you need to be prepared and mitigate for it as much as possible, just as we do and have shared in the previous videos. As we've discussed today, we have services that can react to failures automatically, route around them, and coordinate to self-heal by provisioning new infrastructure for your applications within minutes. We've also talked about the importance of fine-grained observability that you can get when you build in the cloud. This is instrumental in quickly diagnosing exactly which components might be causing bottlenecks or are failing, which helps you to recover faster. This all supports what governments I talk to really care about: minimizing downtime so citizens and businesses can continue to use critical public services.
I absolutely agree. And I would add that being operationally excellent also requires a cycle of continuous improvement. It's an ongoing process. If you'd like to hear more about that, we provide more detailed prescriptive guidance on our website. Just search for the AWS Resilience Lifecycle Framework. So the last thing to do is to say thank you for joining me, Alex, and thank you for watching. Goodbye.